before doing the similar triangles, right? We should know what are congruent triangles. One second. N G R U N T. Congruent. Congruent means same, exactly same. So any two figures we set to be congruent, any two geometric figures will set to be congruent if they superimpose each other, just like my hands. If I keep my hands together, right, the one will hide the other one, right?
So like, so basically like small and big
No, not
shapes.
this one, not this one. I'm just telling that that will be the same. For example, if you take this,
Mm-hmm.
exactly the same. If you keep on one on the other, they will superimpose each other. They will hide each other. As I was taking example of my hands, right?
Mm-hmm.
If I keep my the hand like this, you won't come to know my second hand is behind it because
Yeah.
they superimpose each other. They just perfectly match, isn't it?
So basically, they just look like each other.
Or you can say equal figures. Congruent figures means equal figures. Their sides will be same, right?
Mm-hmm.
Side same. Their angles will be same. Yeah,
Let me write this.
yeah. Side same, angle same, and even the areas are same. Areas are same in case of congruent triangles. Okay, I think
Mm-hmm.
later on we will have a topic on congruency as well, but as of now it is similar triangles what I can see as per the content what you have shared with me. The next topic, the similar triangles and the congruent triangles. The difference is i- congruent triangles are exactly the same triangles. Their sides are same. Their angles are same. Their areas are same. They superimpose each other, right? But in
Mm-hmm.
similar triangles, it won't be the same case. Sides will not be same, but the corresponding sides will be proportional. When I say proportional, right? For example, this is 2, this is 3, and this is, let it be 4. Okay. So the other side now, I'll tell you what proportion I mean by. The other one will be 4, this will be 6, this will be 8. What do you observe? This
It's
side,
like the
this sides are double, right?
yeah.
So that's what. So they all of them. It's not just one side is double. If you see this was 3, then this is 6. If this is 4, this is 8. This is 2, this is 4. So if you divide the proportional sides, right, all of them have the same ratio. 1 over 2, 1 over 2, 1 over 2. Right? If you do other way around, you get 2 to 2. 6 upon 3 and 8 upon 4. See? Right?
Mm-hmm.
All of them have the same ratio. So that is what the concept of similar triangles is. The sides are not same, but they are proportional to each other. The corresponding sides are proportional to each other. Their ratios are the same. Yeah. But what happens in case of congruent triangles? Everything is same. If that is 2, this also be 2. If this is 4, this also be 4. If it is 3, this also be 3. They superimpose each other if we keep it on one on the other. Yeah.
Mm-hmm.
So similar triangles, the sides will be proportional. The ratios will be, but the ratios will be same. The ratio of the corresponding sides will be same. If I again, if I take an example of the same thing, same triangles, EF. So what I was mean by proportion is if you divide the corresponding sides with each other, the ratio will be same. BC upon EF. This you can write it down. and this will be equal to AC upon DF. So the sides ratios are the same, isn't it?
Mm-hmm.
Yeah, that's what I was trying to tell. So whenever the two triangles are similar, their corresponding sides will be proportional. Yeah, and
Yeah.
but the angles will be same. Corresponding angles will be same. This will be equal to this. So you can say angle B equal to angle E, angle A equal to angle D, and angle C will be equal to angle F. Getting it right?
Kind of.
Okay. The similar triangles means their sides will be proportional. As I took an example, no? If it is,
Yeah.
if you're doubling this side or you increasing it with something, some factor, let it be 3 times if you're doing, and this side is 3, this side is 4, everything will be made 3 times. So 2, 3, 3, 9, 4, 3, 12. This is how the triangles will be similar. If it is not 12, let it be 10, then these triangles are not similar because their ratios will not be same. Yeah,
Mm.
makes sense, right? So similar triangles are those triangles whose corresponding sides are proportional. Yeah. If I take the topic from your textbook, what you have shared with me, this is what they have written. 1 second. I took the proper. So what they have written is similar triangles. We have some. We have some. No, the criterions by the basis of which you can prove two triangles same. So one of them is angle. If any two angles of the two triangles are same, you can prove the triangles to be similar. For example, if these two, see, they are taking very good example. They're taking these two triangles, right?
Yeah.
This angle equal to this and this one equal to this. If you prove any two angles of the two triangles same, you can you can say that triangles are similar. You don't have to prove the third to be same. If the two are same means third definitely be same, right? Because one is that, see, why the third would be same is if this is 30, this will also be 30, this is 40, this also be 40. So definitely this will be same only because the sum is same, right? When you do 180 minus that, you get the same answer, isn't it? Makes sense, right? So if you prove two angles of any two triangles same, you can say that triangles are similar. The two angles of one triangle are congruent. Congruent means say equal. That's the meaning of congruent here. They mean by if the two angles of two triangles are equal to each other, then those triangles are similar. Yeah,
Mm-hmm.
makes sense, right? Rasha, are we good till now?
Oh yeah.
Okay, let me take the next one. What they have told.
So it's basically like just the kind of the double, like so if the small one's something, so then the big one's just kind of the double of it.
It's not always double. It can be any ratio. No, another one is side angle
Side angles.
side. I'll take the thing from there. 1 second. So what are we trying to study here is how you can prove two triangles to be similar. Yeah.
Mm-hmm.
So one is AA criterion. If you prove two angles of the triangles to be same, you can say that those triangles are similar. Yeah. Or else, if you have two triangles and if you prove two ratios to be same, you don't have to prove the third ratios to be same. If you prove two to be same and any angle between them to be same, then also it's, you can say that triangles are similar. For example, if two corresponding sides of two triangles are proportional and the included angle of those are congruent, congruent means same. Here it's not
Mm-hmm.
that congruent triangles. The word congruent here means equal. If those sides are equal, then the triangles are similar. Included means the angle between them. So here they have taken AB upon DE, right? This
Yeah.
side and this side. And then they took AC upon DF. And included angle will be A and D, right? Between the two sides, the sides which you are considering for no, for the ratio to be same, this angle between them is called the included angle. You cannot take any other angle. You can't say B equal to E. Then it won't. Then you cannot prove that two triangles to be similar. If you're proving two angles to be similar through side angle side similarity, it's very important that angle has to be included. Included means the sides which you are considering it to be proportional, right? The angle between them. If you're
Hmm.
considering this side over this side, then you have to take this angle only, Pranshul. You cannot take any other angle. Included angle means the angle between the sides which we are considering for proportional. Yeah.
Okay.
Let me share that screen. I think that would be fine. Stop sharing this and let us share this window. This is fine. I think now you can see the screen, right?
Yeah.
1 second. Where did it go? Yeah. What's coming like that? Yeah, all is fine, no? Share
Mm-hmm.
screen anyway. Yeah, no, it's fine. Yeah, no, it's good. Okay, so can you see here? The same thing I'm covering up, okay? So side angle, side similarity. Now, if we go to the next question, see here. Show the triangles are similar. Which one? PRT and QRS, right?
Mm-hmm.
Let me take it to the this thing. Let me take a screenshot. Where are we? Hmm, cannot pre- uh,
Maybe
present.
you can save the PDF.
Yeah, I saved it. I was just thinking if I can present both the things, but yeah, I cannot. So what
Wow.
I'm doing, I shown you that, and then now I'm taking it over here. Okay. So that this questions will come like this, Pranshi. They'll ask you prove that true triangles to be congruent. Which triangles are they considering? PRT. PRT means the bigger one. This one. Yeah.
Mm-hmm.
PRT and QRS, the smaller one.
Yeah.
This one. Yeah.
Mm-hmm.
So basically, let me make it a little smaller for better understanding. So this is PRT, and there's a line here QS, right? So they are considering this big triangle, okay, and the smaller one here, right? Let's take a different color. This one, yeah.
Mm-hmm.
Now, what all they have given to us? They have given that PQ is 18. Sorry, RQ is 18, right? That's what I can see
Yeah.
here. And this QR is 6. And this is 15, right?
Mm-hmm.
and this is 5. So they are asking two corresponding side lengths are proportional. Let's see. So you have to prove two things to be same, right? And included angle we can take this because both of them has the same angle, no? So triangle PRT and triangle QRS, isn't it angle R common?
Angle R. How is angle R common? Like
Both the triangles have, no?
because it's like on the top or
Yeah.
something.
So this triangle also have it, and the bigger one also have the same. Angle R is common to both the triangles, isn't it? So if I take the ratio of these sides, these sides if I take, then I can prove it, these triangles to be congruent. I mean similar. Let's take another, let's take it again. Let's me make it straight lines. Little bigger if I make it, I think that will make you comfortable. Now, this I think was R. What was that? If I take, I think RPT. Yeah. Okay. And this was QS. Okay.
Mm-hmm.
And 18.6, 15.5. 18.6, 15.5. So I and the triangles what we are considering is RPT and RQS. Okay.
RPT and then
So
RQS.
if I take RQ over RP, okay,
Mm-hmm.
what will that come out to be? RQ is 18, right? And RP is how much? 18 plus 6, right?
RP 18.6. Yeah.
18 plus 6, no. So
Mm-hmm.
what will be this ratio be equal to? 9 times 2, 12 times 2, 3 times 3, 4 times 8, 3 upon 4 ratio, right?
Yeah.
Let's take the same on the other side as well. So that will be RS upon RT. So RS is 15, right?
Mm-hmm.
And RT will be 15 plus 5, which is 20. So what will be the ratio be? 3 times 5, 4 times 5. See, it's the same ratio. Here also you got 3 by 4. Here also you got 3 by 4, right? So you
Yeah.
can say that RQ upon RP equal to RS upon RT. One second. RT. The two sides are, the two corresponding sides are proportional, right? And angle R is same. On the basis of this, you can say that triangle RPT, this is a sign for similarity, okay, or one wave sign
Yeah.
similar to RQS. Okay, this sign like this is called similar. We use this sign for similarity.
Yeah.
Okay, you can use for congruency. Though we are not studying it as of now, when we will study, right? So congruency, we have this sign equal to and then same like this wave on the top. So if you have to say that triangle RPT is congruent to RQS, we put a equal to sign and then a wave sign on it. And when it's we are proving similarity, it's not congruency, then we don't put equal to sign, we just put a wave sign. So this we proved it to be same. How did we prove it to same? SAS. We use SAS criterion. How SAS? You took ratio of two sides, right? Side, angle, side. How do you read this as? Side, angle, side criterion. Yeah,
Mm-hmm.
side angle 7, side angle, side angle criterion. That is called SS. And we in the previously we learned AA criterion, right? So if whenever the two angles are same, right? Whenever the two angles of any two triangles are same, you can say that those triangles are similar. Yeah.
Yeah. Gonna write this down.
Yes. Yes. One, two, or more are their criterions, and then we'll do some questions. Easy topic, nothing as such. Once you understand, we can easily go through.
Yeah.
The two triangles, you can prove it to be similar when the corresponding sides ratios are the same, right? When you divide the corresponding sides, the ratio is coming out to be same, or
Mm-hmm.
or all the angles or the two angles, any two angles are same. Then also you can prove two triangles to be similar. Whenever we saying similar means they are not we are not saying they are same. Not we are not saying they are equal. They are just similar. They looks the same. Yeah.
Yeah.
Mm. Congruent means they're totally equal, as we just discussed. Congruency is also a parallel concept to similarity. That's why I'm just covering it. In congruency, it's like everything same, side same, angle same,
Yeah.
area same. When you keep the two triangles on top of each other, they will superimpose. They will hide the other one. Yeah. And there are some criterions with the help of which you can prove two triangles to be similar. So we covered two, which is AA criterion, where we just try to prove two corresponding angles of the two triangles same. If we are able to do that, we can say the triangles are similar. And if they are not, if any two angles of a triangle are not same, they are not similar. They are different. And another
Okay.
one we did is side angle side criterion, where we have to prove the ratio of the two sides to be same and the included angles to also be the same. If you prove the included angle same and the corresponding ratio of the two corresponding sides same, then also we can say that the two triangles are similar. And just in this case, they have given us for some triangle, and with the measurements they have given us, right? And then what we did, we just took the ratio of the corresponding sides, and those come out to be same. And angle r anyhow is same. The included angle is angle r, right? Included
Mm-hmm.
means the angle between those sides which you have considered for proportionality. If the included angle is already same, you can easily say that these two triangles are similar triangles. Yeah.
Yeah.
Hmm.
So can I go to the bathroom real quick?
Yeah, buddy. Go ahead, come.
Okay.